Okay, so today we're going to start with acids, bases, and salts. So let's get started. First of all, what is an acid and what is a base? An acid is essentially a substance whose aqueous solution contains an excess of H plus ions. A base is a substance whose aqueous solution has an excess of hydroxide ions. This is basically the foundation of what an acid and what a base is. Acid is a substance whose aqueous solution has an excess of H plus ions, and a base is a solution that has excess of hydroxide ions. However, in your chemistry exam, when they ask you to define an acid, you are going to define it in terms of it being a proton donor or it being a proton acceptor. So you need to memorize and know that an acid is a proton donor. And a base is a proton acceptor. We do not need to go into details for this. All you need to know is the definition that an acid is a proton donor and a base is a proton acceptor. Okay. Now, there are many different reactions that you're going to end up needing for this chapter. However, the main concept, the main thing, the general reaction in your acid bases chapter is that acid plus base gives salt and water. Very, very important. This is your basically this is the main equation that this chapter is based on. Your acids can be hydrochloric acid, sulfuric acid, nitric acid. There are also acids in organic chemistry like ethanoic acid and methanoic acid. However, you do not need to know them specifically for this chapter. And still, however, these will also follow the same concept that the main ones you need to know will be following as well. My point being was that you will mostly see the hydrochloric acid, sulfuric acid, and nitric acid rather than ethanoic and methanoic for this chapter. And your base, as I said, is anything that has an excess of hydroxide ions. So sodium hydroxide, potassium hydroxide, calcium hydroxide. They're all bases. You can see over here that you got H, you got H, you got H. This is your acid. Then you got your hydroxide. This ion is what gives it its acidicness, its acidic ability. And this ion is what makes it alkali. Now, as you can see, a base having its hydroxide ion, these are alkali metals. So this is why you will also see the word alkali used where base could be used, because an alkali is a base. You have your alkali metal and then you have your hydroxide ion, and that makes a base. So acid plus base gives salt and water. Now, what you need to know, obviously, is that an acid is acidic, a base is basic, and salt is neutral. Acidic, basic, and neutral. Now, what do I mean by all of this? Well, we need a way to measure if our substance is acidic or if it's a base, or if it's neutral. So if we look at the pH scale over here, each substance has a pH value. pH technically stands for potential of hydrogen. Obviously, the more hydrogen that you have, the more acidic it is, right? So pH is basically a measure of how strong your acid is or how strong your alkaline is. Now, if you look here, number 7 is neutral. That is your water, that is your salt, water, salt, and carbon monoxide. All the numbers before 7 account for acidic. All the numbers after 7 account for alkaline. Now, the lower the pH is, the stronger the acid. The lower the pH, the stronger the acid. And the higher the pH, the more alkali it is, the more basic. Now, whatever acid is at number 1 is stronger than whatever acid is at number 4. Whatever alkali is at number 14 is stronger than whatever alkali is at number 10. Now, there was a question in one of the exams as why H2SO4 is stronger than HCl. Now, the reason being is because it has a lower level of pH. And why does it have a lower level of pH? Because it's a diatomic acid. You have 2 hydrogens over here, which makes it stronger than the monoatomic acid that HCl is, because you only have 1 hydrogen here. Therefore, this will fall at a lower point on the pH scale when compared to HCl. So this is very important. You need to know what the pH scale is, what it measures, and how to read it. Moving on, there are different kinds of bases. We already went over the hydroxides. So a base can be a hydroxide, which we saw, or an oxide. Now, an oxide is any metal and oxygen metal and oxygen makes a basic oxide. Likewise, non-metal would have been an acidic oxide. So an acidic oxide is non-metal. Now, is this an acid itself? No, it isn't. For example, sulfur dioxide. Sulfur is a non-metal, and it is with oxygen. This is an acidic oxide. Now, you do not see hydrogen over here. There's no hydrogen, but you know that this is an acidic oxide because this is oxygen and a non-metal. Therefore, it will still follow the same equation over here. When you put this acidic oxide with some base, you're still going to get salt and water. An example of basic oxide would be magnesium oxide or calcium oxide. When you dissolve a metal oxide, when you dissolve this in water, you are going to get a basic solution. And when you will get magnesium hydroxide. And when you dissolve an acidic oxide in water, you're going to get an acidic solution. So those are your oxides. You have 2 oxides. You have a basic oxide and an acidic oxide. And a basic oxide comes under the term of being a base. A basic oxide is metal with oxide, and an acidic oxide is a non-metal with oxygen. One point that I need to mention really quickly, really importantly, is that this main reaction that you see here is called neutralization. Very, very important. This is the name of the reaction, which makes sense because you are forming a neutral substance. Therefore, it is called the neutralization reaction. Now, they might also ask you to write an ionic equation for neutralization reaction. and it is always the exact same. The second you know that it is a neutralization reaction and you need to write the ionic equation, you will always write H plus OH minus gives H2O. This is from the acid, H plus representing your acidic substance, and OH minus representing your basic substance, and water representing your neutral substance, made from the ions that we are already using. This is why in our ionic equation, although you're getting a neutral salt as well, we are representing with H plus ion and OH minus ion, so your product in your ionic equation will be water. Now, there are other reactions that you need to know for acids and bases. All of these are very, very important. We already did the main one, acid plus base gives salt and water. Base ranging from any alkali, hydroxide, or any basic oxide. Then we also have acid plus metal gives salt and hydrogen. Guys, you need to know all of these general equations. For example, HCl plus magnesium gives magnesium chloride, that is your salt, plus hydrogen. Two over here, and we need to balance this as well. There we go. All right. The second one is acid plus metal carbonate. Guys, you will notice that all the reactants that is not an acid is going to include a metal, because the presence of a metal ion is what makes your reactant basic. If anything was non-metal, then it would become an acidic substance. Therefore, always know that your second reactant, it's going to have a metal ion. It's going to be something metallic to make it basic. So acid plus metal carbonate gives salt plus water plus carbon dioxide, courtesy of the carbonate over here. So, like I said, these three are your main, very important general equations. I could give you an example here. Hydrochloric acid plus calcium carbonate gives calcium chloride plus water plus carbon dioxide. And if this requires any balancing, you can go ahead and do that. But I will be moving on right now. So these need to be memorized. These you need to know like your name. Very, very important. There are many times that they give you a reaction and you're going to have to write it in the chemical form. Do make sure that you do the balancing in your exams. Okay, so we went over the main reactions. We went over the pH scale, determining how to determine if an acid is strong or if it's weak. And these are weak over here when it's neutral, and your alkaline, the pH scale. You guys should also be familiar with the colors, you know? You don't have to know them by heart. You don't have to know that 14 is dark purple and 13 is light purple, but you have to have an idea that, okay, if we're in the range of purple, then we're in the range of the strong alkalis. Now, there are a few tests to determine if your substance, if your unknown substance is acid or is it a base. So one thing you will use is litmus, or litmus paper, or litmus solution. Litmus paper or solution. So the color of litmus and acid is red. And the color of litmus and base is blue. Now, how you can remember this is that, whoops, okay, so blue. Basic, B gives blue color. So obviously if base is blue, then acid is red, because they're the only two colors that you will be needing. This is just extra information that when it is neutral, litmus is purple. However, I do not think you will need that for your IGCSEs. Then we have the same thing with a solution. You can just add a litmus solution onto whatever substance you have over here, and then it will change color according to if the substance you added is an acid or if it is a base, or if it's a salt solution. We have methyl orange, which is also red in acid. It's yellow as a base and orange when neutral. Then we have this one right here, which God knows I've tried to pronounce way too many times during my GCSEs and I have given up. This one is colorless when acid and blue when it is a base. Again, you need to know these colors, you need to have them memorized, and for your information, thymolphethylene, I hope I got that right, is a new addition to the syllabus, so it is likely that you are going to be tested with this indicator now. And by the way, all of these are indicators. They indicate if you have your acidic substance or if you have your basic substance. So we went over the definitions, we went over the reactions, we went over the pH scale, and we went over the indicators. I believe that is enough for this video, and we will continue this chapter in the next video. If you guys have any questions, you want me to repeat something, comment it down below and I will get right to it.